we're delighted to have Thomas Rabb and Alexander Bonaj and Patrick Drohan, who are giving a three-part talk on the characteristics and legacy effects of historic raised beds in northwestern Ireland. Initial findings from a geopedological approach. Now, Thomas and his colleagues have worked quite a lot in Ireland. They've been working in Ireland for the past 5 years. They come over for a few weeks in the summer, and they work quite closely with a lot of the farmers in the northwestern part of Ireland. So it's something new, a new approach, and we're very excited to hear their talk. Thomas is going to talk about himself and the other speakers as well. So we'll give an introduction to what they do and where they come from. Thomas and Alexander and Alexandra and Anna are from Germany, from Brandenburg, and Patrick Drohan, he's of Irish ancestry. He's in Penn State University. So welcome everybody. And with this, I'll hand you over to Thomas. Thanks.
Yeah, Ellen, thank you very much, and welcome to the other guys showing up here for this talk. It's a great pleasure and honor to give this presentation together with my colleagues, who are already been mentioned. So I will give an overview, about 12 slides, something like that, just who we are and what we did, and then I will continue or hand over to my colleagues here. So this is the outline, as you see. So I will give you a little bit of a background why we are so interested in these raised beds. And then with the third part, Alexander will continue showing you what we found out so far. And originally, Patrick would have told you more about the perspectives why raised beds are of interest and wider interest. Unfortunately, he's stuck in New Jersey at the moment, where they facing quite a storm there. So I'm not sure whether he can show up or not. Anyhow, I have prepared some slides to give you that perspective as well. So just to introduce ourselves a little bit, so that you know who we are and what we are doing. I already mentioned Patrick Drohan, so that's this guy here. So his father was born Irish. He's a professor of pedology at the Penn State University in the USA, and he's mainly focusing, of course, on soil science, but also into watershed management and landscape ecology and natural resource management. He is actually every year in Ireland with students from his university, working together with Teagasc. So he's quite experienced in land use and agriculture in Ireland. So Alexander did his PhD 2 years ago in my group at BTU. He also did his master program here, and he's now a postdoc working on soil development and also using more sophisticated techniques in the laboratory and digital elevation models. So the two ladies to the right you see here are postdocs. I would not call them postdocs anymore. They are really senior researchers. So Anna Schneider gained her PhD 2013, and she works on geoecological aspects and soil geomorphological issues, mainly also focusing on past land use and the legacies with a special expertise in soil physics. Alexandra, my colleague and wife, did her PhD at the University of Potsdam in Germany on quarterly geology, lake sediments in Siberia, and together we work here at BTU since almost 20 years on geomorphology and soil science issues. So to introduce the group and what we are doing, So as already mentioned, I'm a professor at the Brandenburg Technical University in Cottbus. That's about 1.5 hour drive east of Berlin, very close to the Polish border. My background is physical geography, and I focused then on coordinate science and geoecology. And so we mainly study the interaction between soils and landforms. Our group has 5 to 10 people, PhD, master students, something like that. So we are mainly interested in this really upper part of the Earth, where we have these very thin interface, which we call the soil, and we are mainly focusing on a landscape perspective. So we often talk about soil landscapes or the pedosphere. And in the recent years, a lot of these legacy effects were part of our studies. We look on the properties they have and what processes are going on then, and there are also some of environmental issues we would like to deal with. So the methods we are using is really we start from profile, soil profiles. We also use experiments in the field. We have a laboratory where we analyze basic parameters. A greenhouse sometimes is part of our experiments, and the part here to the right is the one where we focused more in the last years, especially the usage of geophysical techniques like GPR or EAT, and Alexander got quite an expert in the usage of drones. And then later on, or as a last step, we use that data in the GIS to map and to provide models, for example, for soil organic carbon. So that's who we are. And before Alexander will start giving you some results, I would like to frame this a little bit, why we are so interested in these raised beds. So as mentioned, during the last years, these small landforms from past land use got more attraction, and some of you guys already know that we work on these relic charcoal hearths. So these remains of former charcoal burning activity. There are other aspects from former agriculture, which we call lynchets, and I will show you some examples from this and from that perspective. The cultivation ridges, this is something like ridge and furrow systems, more related to or quite similar to the raised beds, and mining remains were also some studies we did in the past. All of them are characterized by these morphological features of very small dimensions. That's why we call them small landforms. So some of them just have heights of 30 centimeters or something like that. And these high-resolution digital elevation models we now have from LiDAR data set the basis for all of the study we did in the past and we are doing on now. So just 2 examples of these small landforms. This is a feature we are studying since 10 years almost. So these are platforms from charcoal burning. You find these historic illustrations here. So these are upright kilns, or however you call it. So there's a discussion about that. So the US mainly call them hearths. As you see here, also from Connecticut, as mentioned, they have these very specific round features or knob-like structures in the digital elevation model because the platform is a little bit elevated, which has been left over. Some cases you have boulders also that have been used to construct platforms, especially in sloped terrain. And that leads over to the classification. There's a paper from Florian Hirsch, who was formerly our group, published this part of a classification thing that according or based on the morphology, it's possible to classify these platforms like on the slope. Then they also have very distinct layering due to construction, or if they are on a just on a plateau or something like that with no inclination, then the stratigraphy is rather simple. So regarding the source, which we are mainly interested in, there is really a distinct feature which we see in all of these profiles. Here you see 4 pairs of profiles. Always to the left, we have a reference profile, and to the right, just 10 or 15 meters away, there is the profile on these relict charcoal house or on these platforms. All of these relict charcoal house soils exhibit this almost pitch black horizon. Some of them have these layering, and you see on the distribution, you find them in northern Germany, in southern Germany, you find them in the US, and you find them also in other parts of the world, even in Ireland. There's a lot of information now around on these relict charcoal house, and this is a very detailed image taken from Alexander's PhD thesis. He worked in Connecticut, so northeastern USA. He used this information which he gathered from the area which is called Litchfield area. This is a former iron mining district, and then with all the soil profile information, he derived a model to calculate the soil organic carbon content, the additional soil organic carbon content, which is caused by these relict charcoal, because if you look at the profiles, you can imagine that there's a lot of charcoal left over from these 1900 from these activities in the 18th and 19th century. And this was quite an interesting result that in some areas, the total organic carbon addition can be quite significant. You see here also some densities, more than 200 relict charcoal per square kilometer, especially in this part where I did a study. So the mapping was done by LiDAR data, and depending on the scale you're looking at, you can have really high numbers of pyrogenic carbon, which additionally can be found in these systems, in these forest ecosystems, not seen so far. Coming to the next example of these small landforms brings me to what is called the lynchets. So lynchets might be seen as a kind of a terrace, but actually they form quite differently. So lynchets also have these very distinct features in the digital elevation model. We can find them on open grassland or pasture, but we also find them in forests. There is a recent paper from colleagues from France developing this very nice model, how lynchets evolve. So you have the forest, and you have a clearing, and you have the slope, which is split up in different plots. And then with agriculture usage, you have erosion and accumulation. So these lynchets evolve more and more with the formation of colluvial deposits at the border of these plots. So actually they are not like terraces. So Anna Schneider works since several years on these kind of landforms in southeastern Germany, specifically in northeastern Bavaria. Just to show you some aspects of her work here, you see the landform structure here. You see features from, or this is a measurement from ground penetrating radar. And if you look at one of these edges of the lynchets, we see the this is the former surface, and this is on top we have all the material which has accumulated on that edge of the lynchet. So interestingly, if we look on ERT images, and this is also confirmed by other data, the red signals shows that these lynchets are drier than the other area. So there's also, again, some kind of an ecological effect, or what we call a legacy effect on the soil properties. There are also some dates from 14C just to show you what age these lynchet system can have. It's not so we don't go into detail in all these dates. What I would like to highlight is all these lynchet systems show these very clear layering of colluvial material on top of it, right? And a more detailed story to be published soon is that also there seems to be some kind of a legacy effect of these lynchet systems, of these colluvial deposits. If we look, for example, into element concentration, the nutrients like carbon and nitrogen, so that they differ between lynchet systems in yellow and reference systems in green. And there seems to be also a difference between younger and older systems. So summing up this, before I hand over with the next slide to Alexander, just to give you the background here. So because the point was, what is geobiology actually? So it's a combination of studying landforms and soils. We see that a lot of these properties we have nowadays are really have a history, so that this is a legacy effect. So there was a pedosphere in the past. This has been formed through cultural activity to humans. We have now a status quo, but of course, for the future pedosphere, a lot of these properties simply have been inherited from these past land use. And that's maybe the start where Alexander could take over.
So yeah, hello, I'm Alexander. Thomas already introduced me. I'm a postdoc here, and I want to quickly get back to this slide from my PhD thesis, because it helps to explain a little bit or at least my way of thinking and our approach for our research in Ireland. Because here we not only looked at a couple of these old relic charcoal house sites, these anthropogenic landforms, but we actually looked at tens of thousands at them. So the way we did this is a combination of field work, where we went to the sites, did our sampling, did our analysis, and then we also did some very broad scale mapping of these sites using available LiDAR data in the US. And we also used some AI methods for automated detection of these sites. So it's a way to make this more faster and less prone to error, the mapping, and detected some, I don't know, 35,000 sites in Connecticut. And this really enabled us to transfer all the information that we got from these single sites to a bigger scale, to a landscape scale. And then, as Thomas already mentioned, he made these kind of estimations here, for example, about how much carbon is still in there. So what is really the effect from a site to a landscape from this old historic craft on today's landscape? So yeah, just give you an idea about my way of thinking. And now we're going to finally come to point 3, to the raised beds in Ireland. I think for this audience, I don't need to explain what a raised bed is, how it's constructed, why it was constructed. So this is a very old way of working with the land, of agriculture in Ireland, mainly for potato harvest. And we assume that all the remaining raised beds that you see today have been abandoned at the end of the Great Famine catastrophe in the late 19th century. So these are all quite old and are still visible today. So we already published some information from our first fieldwork here in this publication. I will put a link into the chat later on. You can all access this. This is open source, not open source, but open access. And yeah, I'm also going to briefly go over the results in this presentation. But first, for our overarching goal, you saw our geopedagogical approach to things. And here in Ireland, we want to start with, so we submitted a proposal to the German Research Foundation for funding. And in this first proposal, we said, okay, we want to look at the specific fingerprints that this historic form of agriculture still has on Irish landscapes. And we look at morphological fingerprints. So how do these sites look like today? How can we identify them using aerial photography, using maybe satellite imagery, using drone imagery, using LiDAR? Then the question is, will the morphology, so for example, the spacing of the ridges or the height of the ridges, will it change depending on where we look at the site? So maybe in the, I don't know, northwestern part of Ireland, these sites will look different than in other parts of Ireland, depending on topography, depending on soil conditions, and so forth. So here we also want to try to create a catalog of sites, or types of sites. So that's the morphological fingerprint. Oh, another aspect here, we want to look at if these sites that we still see today still fulfill their original purpose, which is to drain the landscape, or the main purpose at least. So are they still having that function in the landscape? So we have some preliminary modeling here for soil wetness, but more on that later. And we mainly use for this task UAV-based imagery, so drones. And we have thermal imaging drones, we have multispectral imaging drones for different specific research questions in the project. Then the second part here, the pedological fingerprints, then deal with the soil properties of these sites. So how are soils differing on these sites compared to other fields where you don't have this raised bed structure anymore? So can we prove, for example, based on the soil properties, if there was specific historic soil amendments were used, for example, seaweed, crushed limestone, or seashells in coastal regions? Then other questions like, is the organic matter content changed in these sites? Is the soil wetness influenced? Are vegetational patterns influenced? So is maybe the grass growing better on these old raised bed fields than on adjacent sites? How do we even classify these soils on these anthropogenically changed sites? It's always an interesting question. And then, maybe we can derive, when we just look at the soil on the morphology, how were these sites actually constructed? Were they constructed using hand tools or, I don't know, plows, whatever? What can we see on the soil? So then these are the pedological fingerprints we're looking at. Another interesting question that always comes up is, how do we actually find reference material? So when we talk about, for example, changed carbon contents on these sites, what do you mean by changed? What is this relatively to? So you kind of need to find soils to sample that were definitely not influenced by this practice. And the best we came up with so far is to look under these stonewall foundations, these boundary banks that are everywhere, of course, then under the bigger hedge banks. And yeah, so that's what we thought of. So that's just for a general broad overview of what we're actually aiming for with this project. And now I can show you some results, but this will be more about what we plan to do in the future than what we already have done. So this is from our first fieldwork here, focusing on Leitrim and Roscommon. And we looked at 3 sites here. We choose the sites based on their topographic position, their soil conditions, and their morphology. We did the UAV-based imagery, so we flew over the sites, took thousands of pictures. We applied geophysical methods like ground-penetrating radar and ERT. And yeah, some of the results. Oh no, wait, this is still on the sites. So maybe that's too much detail here. So one of the sites is on an old peatland. One is on a steeper slope with limestone till, and the other is on a more flat terrain on the drumlin. Yeah, we got access to these sites just by local contacts, going to the landowners, talking to them, and so far everyone we encountered was very interested in what we're doing, very friendly, and they had absolutely no problem with us doing our research there. So this is what the first site, we call it Tommy site on an alluvial floodplain. This is old peatland, looks like in Google Earth imagery. This is what we would see when we scout for these sites. We look at Google Earth, see what looks good, and then try to make contact with the landowners. You can see the ridge and furrow structure here. This is what the composite of the drone shot looks like. More details. You can also see the ridge and furrow structure here, but of course, this high resolution data enables you to make your own digital elevation model out of these drone shots, and then looks like this. It's a little bit noisy because there was tall grass growing on this side, but you can nonetheless very well see the ridge and furrows here. You can also see a lot of other archaeology here. So on the left side, there is some kind of foundation here, the rectangular almost in structure. You have like a pathway leading to the northern direction, but there's no further information on that. Now try to make a sketch here of the ridge aspect and the spacing. So on this side, the ridges are very broad and very straight. And compared to the other sides, which we will see shortly, it led us to the conclusion that here maybe there were different tools used than for the other sides. Maybe not spades, but some sort of plow or even some kind of machinery. But that's just a hypothesis. Here we also encountered a nice effect during fieldwork. So we started digging, and over time, more and more people showed up to help us who were very interested in what we're doing. And then after 40 minutes, someone said, "Oh, I also have an excavator." So yeah, then he brought his excavator, and the work was done quickly. I don't want to go into much detail here on the soil, so I'm just going to skip this, go to the second site. This was on Mount Shimor, and this is a bigger site. That's why maybe I hope the compression is not too bad. I hope you can still see some details here. The ridge and furrow systems, so there were multiple systems here. On the DEM, it looks like this, and I can just maybe use this magnifier. Hope you can see that. So you have multiple aspects here in this ridge and furrow. Some are not even really straight, some are with a curve, some are smaller, some are bigger. So we hypothesized that this is the result of multiple former landowners, of course, doing their agriculture there. And we sketched this again. So this we thought was the more a handcrafted site with narrower ridges and not so straight ridges. This is what the soils look like here. So very shallow soils on this side. So we were actually amazed because we learned that there were like 800 people living on this relatively small hill. So to think of that they lived off this soil was amazing to hear. Then this is the third site on the drumlin, and here again the digital elevation model shows us the details of this former field system in great detail. Here you also have some more recent disturbances of drainage channels, deeper drainage channels going across the field. You also have traces of some old housing foundations in the lower part. And again, here we had more wider ridges, but also very uneven ones. Here, the former landowner actually plowed this field relatively recently, resulting in this very sharp boundary that you see here on this transect. But we were surprised to see that regardless of the plowing, you could still see the ridge and furrow system quite nicely on the DEMs and also in the field. Yeah, which was important information for us. Now here, I also don't want to go into too much detail, but this is the first result of our attempts at doing some surface hydrology modeling on our DEM data. Now, admittedly, this first run of gathering the drone data was mildly successful because we had a very simple drone back then in 2023. So the DEM quality was not that good. But nonetheless, we could do some first modeling and basically show that based on these models, the furrows are still wetter, the wetter position in the landscape. May not be the most surprising result, but it was important for us to see sort of as a proof of concept of the methodology we want to apply in the future. So we can use this drone, even a simple small drone, to gather data in a resolution high enough to do this kind of modeling successfully on these sites. Now, I already mentioned how we detect them, how we map them so far. And there were some problems we encountered. Yeah, we had a lot of false positive detections. So during our scouting trips through Ireland, we looked at the Google Earth imagery, and there's an example here where on the left side, we had a potential candidate site, and you can see the linear structures here. And then we went there, and on the right side, you can see the actual site condition, and there were no raised beds there. So this was a real false positive detection. And we think that on the Google Earth imagery, what you see is actually just lines of hay or something that was there on the field, which was gone when we actually went there. Another example here from higher altitudes, again on the left side, what we saw on Google Earth. And then on the right side, this is, of course, not a raised bed system. This is drainage for peat harvesting. And another example where the potential raised bed system was more recently created by presumably some forestry operations here where they plowed the site to plant trees or something. So yeah, so that was a problem for us. A lot of false positive detections happened, and what we could also gather until now was some information about what kind of resolution for the LiDAR data do you actually need to see this, to see these sites on the LiDAR, on digital elevation models, sorry. Mm-hmm. And you can see that anything below a 1 meter resolution, basically you lose so much information on this ridge and furrow system that they're barely visible anymore. You can't do any kind of modeling of surface hydrology. And yeah, so most optimal will be a resolution of 50 to 20 centimeters, maybe even better, in terms of the LiDAR data that you need to get. Now, you may wonder why we always, or maybe this audience will not wonder, but why did we only use Google Earth and drone-based imagery and drone-based DEM data? Because at least to my best knowledge, there is no available LiDAR data in Ireland, at least not on a large scale. Maybe for single small patches, but it's not a wide coverage available. And especially there's no coverage in the resolution of LiDAR data that you actually need to actually see these sites. So remember I showed you in the beginning this slide from my PhD where we did this very large mapping of for a whole state in the US. And I originally wanted to do this in Ireland, but yeah, how do we actually map them? There is no LiDAR data for us available. Maybe this will change in the future. I don't know. We don't know. But we can only hope. So yeah, that's the question for us now. How do we actually efficiently map them? We have seen that using Google Earth can result in a lot of false positives. And yeah, LiDAR data is just not available. Now, the second part here, this is from our fieldwork last year. All the data we gathered here is basically still it's still in progress, so there's nothing published. I'm still working on processing all the drone data, which was quite a lot. So this is going to be more a slideshow of us working. So this time we actually had bad weather for our first field trip 2023. We had the best weather ever. And now, yeah, I guess we experienced the true Irish weather for the first time. So it was raining. Here you can see us working on one of the sites. What you can see here is the ERT. Geophysical methods. I'm working on the GPS system here. And you can also see this former raised bed field system here that we're looking at. Yeah, fieldwork was quite scenic. So was really a nice field trip for us. We got help from the locals here guarding us during our work, but also real practical help. So this was a interested local who actually took us on his boat in Clew Bay to a nearby island where they had really good raised bed systems. It was quite the adventure for us and for him too. And again, very, very scenic working conditions for us. And this is another example I just wanted to briefly show. From another site, this was a rather steep slope. The whole dimension of this site is more than 1 kilometer in length. I hope you can still see something from the details. So what was interesting here, that there was a lot of other archaeology on this specific site. So there were all housing foundations, the stone walls here, and all these stones that you see there were presumably were a larger structural ones. And the raised bed system you can nicely see here on the composite image. Maybe it's better visible on the digital elevation model. You can see that here, the linear features. See them here. You can also see a lot of old foundations there, these rectangular features. And then the more you go upslope, the more you encounter these old foundations, stone walls, whatever they are. So yeah, I mean, I mentioned that we also use the thermal imaging. We also use the multispectral imaging. So coming to an end now, just give you some examples. This is a normal image, and this is the same spot using the thermal camera. And you can see there is a little signal here. So you can see these linear features of the furrows here, which are apparently a little bit cooler than the ridges. So apparently the thermal imaging somewhat works in detecting these sites, which gives us an important clue here that so where's this coming from? It's vegetation. So the furrows actually have more grass growing in them, have taller grass growing in them, and they are wetter. So this is an important indication for us that there actually is something there in terms of change in ecological microhabitats on these raised bed sites. And this is just the last example here for a multispectral image. And then again, we see in the near infrared, there is a little signal here indicating that these furrows have different properties than the ridges throughout. Yeah, I have some more examples here, but that's, I think, now also too much detail. So we did the geophysical methods, the ERT, which also showed us that the furrows are indeed still wetter than the ridges. And yeah, with that, I want to give originally back to Patrick, but now I think I'm going to give back to Thomas.
We have learned since the last 3 years and what we look forward to. So definitely these landforms like the raised beds, we could put into this category of cultivation ridges. There are some other examples from the North European lowland of ridge and furrow systems that reminds us that they are quite similar to these raised beds, although they have a different history. So we see these raised beds as definitely a legacy of the past land use, which is worth to be studied more in the context of small landforms who which have distinct features also from the perspective of the soils and their effect on the ecology. I think Alexander highlighted very well at the beginning where he showed the outline or the strategy of the proposal we talked about, that there are still a lot of questions around, not only related to the ecology or to the history, but what do these, or what effect do these raised bed systems really have until today? So do they control the hydrology? Is there still a drainage effect? Is there the soil organic matter affected? We see, of course, effects on the physical properties. And is this also then, if we sum it up, as we have experienced this with the relic charcoal house, so that in total, this is really a significant number for, let's say, the sources or sinks of nutrients and the drainage effect. And there are, of course, related to the mapping, a lot of questions: how much area is really covered? So what, kinds of raised beds do we see, and what's really their spatial distribution, which is, of course, also related to the history and the people living there. So these are just some of the questions coming up into our mind, what is interest to look forward. And of course, we see that these raised beds are just one component in a very complex cultural landscape you guys have there in Ireland, and that there might be also a discussion about what is really the heritage value of these kind of past land use systems. And this is certainly something Patrick is also interested in. And maybe we have another occasion where he can be with us, where he can explain more of these ideas of this heritage aspect. So, and yeah, that's our report for the raised beds in Ireland, and our experience with the Irish people, which has such an open heart, and we always have seen so many options to work there due to the help of these people there. So thanks to the audience, and thanks to the Irish. Thank you.
That's great. Thank you, Thomas and Alexander. Really great talk, something really different, to lots to think about. Your images were fantastic. And it's great the way that you work with the community, and you're working with the farmers, and building up the narrative and the history of these raised beds. So if anybody wants to ask any questions, you can put them in the chat, or you can raise your hand if I can't see all the hands. We do, Paul Goslin, I don't know if you saw, there's high quality LiDAR available for Clare Island in Clew Bay. So if you want, it's an island which is well known for the excellent preservation of ridge and furrow cultivation ridge. So if you want to contact Pete Coxon, yeah, I'm sure you know Pete Coxon, I can give you his number. And then Alexander has a link to the paper as well. So if everybody wants to take that link down, and I can send it out to the people that were at the talk as well after the talk. And then Barry is going to ask a question. Barry Fitzgibbon, if you just want to mute yourself.
No, a very just sort of a very general question. I kind of work in the area. I kind of work in the area of assessing developments in particularly the northwest of Ireland, and particularly rural kind of less developed areas, and I kind of come across raised beds quite frequently, and I'm always at odds as to how to assess them in terms of their significance. And I was wondering if, I appreciate that your third speaker was probably going to speak more on this specifically, but I was just wondering if anyone could give insights as to the significance of these raised bed sites, kind of on a, say, are they common internationally? Are they a unique aspect of Irish culture? Irish agricultural culture. Is there anything else that I should maybe consider while looking at these sites, and if say development in the area that may have obvious raised beds? As I say, I kind of come across them a fair bit, but just some sort of context, maybe if somebody could speak to that.
Yeah, okay. I'm not sure what the question is to me. What I can say is that for us, we are not very experienced in Ireland, so we work there since 4 years. So Patrick knows the area more. You know better the area, your country, than we do. What I see from an international perspective is that there's not much research on raised beds going on. I've seen them in Scotland too. I've seen that, but looking at, so let's say, at scientific literature, there's not much about raised beds. There are some papers also from Ireland. Some, I'm not sure if they are from Clare Island. Thanks for the comment. Yeah. So there are some approaches also looking at what can be found from, let's say, the former amendments, but not very much. So there's definitely not as a systematic approach to study raised beds from what I know from the literature or the reference. Not sure if Alexander would like to comment this or.
Yeah, there's not much published really. Maybe on the archaeological side there's more, but in terms of our realm of research, soils, geomorphology, there's very little. What I just wanted to say, so we saw this effect, for example, with the relic charcoal hearths in, for example, Germany, which were relatively unknown before the widespread availability of this high resolution LiDAR data. So as soon as this LiDAR data was made public, everyone had these high resolution elevation models all of a sudden, and then we discovered, okay, directly in front of our houses in the forest, there are tens of thousands of these old relic charcoal hearth sites. And then, of course, the question came up, so what do we do with them? Are they need to be protected? Do we need to set up some protection status for them? And I think this is a question that could come up here as well, when there is, as you said, you encounter them all the time, and we also encounter them all the time. Once there's LiDAR data available, I think people realize that they are very widespread, at least in the northwestern part of Ireland. And then the same question will maybe come up. So what do you do with them in terms of their heritage status? Do they need to be protected? But then all of a sudden, large areas of your landscapes are protected and can't be worked on anymore. So I think it's a sensitive question for the future. But maybe the audience has opinions on that, so I don't know.
What about dating them? Had you any thoughts about how you could date them, or are there, certain forums that date to certain times, or are they just random? Or have you a sense of how far they go back, or?
So we don't have direct datings available. It's quite difficult. So what you could do is 14C dating, for example, but then the question is always, what do you actually, how do you interpret the results? So we only have indirect datings available. As I mentioned at the beginning, we hypothesized that all the sites we're looking at are from like the middle of the 19th century, around when these lands were abandoned by the people. So they just left, and then what remained were these scratches in the landscape from their field systems.
Okay. Thanks. Are there other questions? Sally has in the chat. I know Sally was looked after you there during the summer. She met you and showed you around. So thanks, Sally. But she was saying it was just lovely to meet you in the summer. And have you identified sites to target for 2026? And we're all very interested to see more data from the 2024 work when it's published. So plans for 2026.
Yeah, I just wanted to answer in the chat, but I can do so, right, sure. Yeah, at the moment we are waiting for the outcome of a proposal we just submitted to get funding. So for now, we do not plan to have, at least not a major field campaign 2026 in Ireland. So that this will be mainly, yeah, determine whether we got funds or not. So as Alexander also mentioned, we still have a lot of samples to analyze in the lab and to work on the data we have so far from the drones. So as said, possibly not a field trip in 2026 for going for new sites. As said, it will be a matter of the funding. We will hopefully we will know in January about that. Then we would of course love to come back. Maybe it's more now the point to think about not only visiting new sites, but more what to do with the sites we know so far. Maybe more to map them and to yeah, organize and categorize the data. Yeah, we are still curious about the situation of the LiDAR data in Ireland. And as Alexander just mentioned, so this is really a game changer for these kind of research. If you have publicly available high resolution LiDAR data, then from that point you can really produce a lot of information. With the approaches we are using with the drones, it is very much restricted to more local or regional things, which we did so far. So to sum it up, it's a matter of the funding, the capacities we have as a group, and the digital elevation models as they come available. I'm not sure if Alexander has something to add.
No, I don't.
That's it.
No. Are there any other questions? Anybody has a question? Would they like? Emmett Burns has a question there in the chat. Notwithstanding the postulated date generally of the sites investigated, are there any characteristics, examples, soil chemistry, organic content that indicate intensity or duration of use of individual rows? It's very interesting. Yeah. Can you?
It's a very interesting question and right on point. So, but there's no answer yet. We're still working on it. Yeah. But that's also in the direction that we're going with our hydrological fingerprints.
There was a very interesting discussion we had after our talk we have given to the Newport Historical Society by a local there. We just the day before we visited sites south of Louisburg, were really very well expressed raised beds, the best we have seen so far. And he mentioned that in the area, the raised beds, and they are very close to the shore. So these raised beds, which have very, very good ridges and furrows, they seem to have been constantly being used, of course, with seaweed, and they have not been a restructuring of the raised bed system so that the furrows and the ridges have been switched over the years. So this is what we just got from the locals. But as Alexander mentioned, all these things on soil chemistry, organic content, and these kind of things. So this is a much bigger project which needs to start once we have a better perspective how to continue with this work. So we definitely would like to do that. And there are discussions and plans from Alexander with Patrick together to do some analysis on the samples we have from the last year to determine or to analyze the basic parameters like carbon, nitrogen, phosphorus, and something like that, especially related to the question, what is really the long-lasting effect or the modern effect of these land use systems on hydrology and the nutrient situation in these landscapes. So it's on our table, but we don't have answers yet.
Yeah, and another point really quickly, in terms of the soil properties that we may that we maybe can answer with our analysis is the soil amendments that they use. Say it's known that people used manure, seaweed, and stuff like that. But for example, for the seaweed, how far was this transported inland from the coast? So maybe these paleological fingerprints that we are analyzing can give us information on that. Example. Just another question that we want to answer.
Thanks. Yeah. Any other questions or don't see anybody's hand up. No other questions in the chat. Oh yeah, I can see everybody now. Yeah, no other questions. So with that, I'd just like to say that was really interesting talk, highlighting something that's not looked at quite a lot in Ireland, but it's everywhere. Our raised beds are all over Ireland, but it's highlighting how important these raised beds are. And your studies, we're really going to look forward to the results of your studies, and hopefully you'll come back to talk to us again. And we were delighted that you took the time out to talk to us about your work in Ireland. So thank you very much, and we look forward to hearing your results from your geochemical analysis. And yeah, very interesting. So thank you very much. Just before you go, our next talk is on the 4th of November. It's in person. It's in the Antiquities, 63 Merrion Square, and it's by Dan Hicks. And he's just he's going to talk about his new book, How Every Monument Can Fall. And that's the 4th of November, 7:30. And if you want to sign up, I'll send out information in the next updates, or just email me at archaeology@iai.ie. So thanks very much, everybody. And if anybody has any questions, they can send them in to me as well, and I'll send them to Thomas or Alexander. They're very keen on working with us in Ireland. So it's a good start. So thanks very much, and we'll all see you all on the 4th of November.